Good morning, dear students. Last session we have talked about high strength concrete, where we have just recalled the information regarding basic constituents like coarse aggregate, fine aggregate, and binder, and the aggregate related information like the properties, important properties of aggregates. What are the desirable properties for the aggregates, and also the maximum force aggregate size is also being presented. If you just can see that this should be the lowest of the following three quantities, like 1/4 times the minimum thickness of the member, spacing between the tendons or strands minus 5 mm, and 40 mm. So least of the three shall be the maximum size of the coarse aggregate that you are going to use in preparing pre-stressed concrete. And you shall see that you have to, the coarse aggregate shall be free from all these matter, right? Deleterious matters. Okay, like pieces of wood, clay lumps, coal, silt, rock dust, all that. And all this information is given in section 5.3. I mean class 5.3 of IS 13432012, which is the latest code after 1980. IS 1343/1980. Okay. Right, let's talk about the cement now. So in preparing pre-stressed concrete, uh, the cement is the one which uh, the main ingredient that you can say. Cement is a mixture of limestone and clay heated in a kiln uh, to 1400 to 1600 degrees centigrade. So the types of cement permitted by the IS 1343/2012, where clause 5.1 will give you the complete information about this regarding this cement that you are going to use for pre-stressed applications. So these are the following cements available for use in pre-stressed applications, where as and when needed and depending on the requirement. Okay, so 33 grade of OPC conforming to IS 269, 43 grade OPC conforming to IS 8112, and 53 grade OPC ordinary Portland cement conforming to IS 12269, and rapid hardening Portland cement conforming to IS 8041, whereas Portland slag cement conforming to IS 455, and pozzolanic cement like Portland pozzolana cement, which is fly ash based, conforming to IS 1489 part 1, and Portland pozzolana cement, which is calcine clay based, conforming to IS 1489 part 2, wherein hydrophobic cement conforming to IS 8043, low heat Portland cement conforming to 12600, and sulfate resisting Portland cement conforming to 12330. So other than these three, the remaining are, for the specific purpose. Okay, as you can see those names, like pozzolanic cement, slag cement, hydrophobic cement, where water resistant if you want, and low heat Portland cement, where you don't need, where you need to arrest the cracks from the heat generated from the cement upon reaction, and wherever the sulfate attack is very high, you have to use sulfate resisting Portland cement. So these are the uh, uh, cements available for use in pre-stressed applications. Coming to the water, the water should satisfy the requirements of class 5.4 of IS 456-2000, and you shall see this one. Like, however, use of seawater is prohibited. Okay, so use of seawater is prohibited. You cannot use seawater for preparing pre-stressed concrete. The water used for mixing and curing also shall be clean and free from injurious amounts of oils, acids, alkalis, salts, sugar, organic materials, other substances that may be deleterious to concrete and steel. So, in general, even when you want to prepare normal PCC or RCC, we just say that potable water is generally considered satisfactory without any testing and all. Uh, you can use it in concrete. So the water that is potable, normal drinkable water, which is in general is considered as good, suitable for use in concrete, both for mixing as well as curing also. Both for curing also, you shall use potable water. The average 28 days compressive strength of at least 3 cubes of 150 mm concrete prepared with water proposed to be used shall not be less than 90% of the average strength of three similar concrete cubes prepared with distilled water. So to test whether the water that you have to use is suitable or not, what testing you need to be done is take the water, some X source X, prepare 3 cubes of concrete with that water, 150 mm cubes, and also prepare with the similar ingredients. Instead of the sample X, use distilled water, prepare the similar cubes, concrete cubes, and you can see the condition that the 28 days curing, after 28 days curing means after 28 days immersion into that some X water and distilled water, you should see that the condition, it shall not be less than 90% of the average of strength of three such similar cubes which are prepared from distilled water. Okay, then you can consider that water. If you are not sure that whether it is potable or not, you want to test that whether that water can be used or not. This is the technical information that you can rely on. Okay, and also that is about strength requirements of the water. And also the setting time shall not differ by 30 minutes. Means what we say, we generally initial setting time shall be 30 minutes. Okay, so the water that you use, if you prepare the concrete, and the initial setting time shall not differ by 30 minutes. Okay, and the pH value of water shall not be less than 6. Okay, so which means it cannot be acidic. The water cannot be acidic in nature. Okay, so less than 7 is acidic, more than 7 it is base, right? So the water that you take for usage in concrete shall not be acidic. Right. Coming to the admixtures, where in IS 1343 2012 clause 5.2 and 5.5 will say that all the admixtures shall comply with all the requirements presented in 9103 1999 IS code 9103. Right. The admixtures are two types. Okay. One is chemical admixtures and another mineral admixtures. Right. Chemical in the sense liquid form. Mineral admixtures will be in powder form. Okay. Right. What are all chemical admixtures are available? Air entraining admixtures, water reducing admixtures, set retarding admixtures, means setting time reduction, set accelerating admixtures, setting time increasing, okay, to increase setting time. So, I mean, so accelerating, setting time to speed up the setting time, slow down the setting time. That way we can understand. Okay, set retarding, slow down the setting, set accelerating, speed up the setting. Okay, likewise water reducing and set retarding, water reducing, set accelerating. Okay, I mean quick setting, something like that. Okay, and common mineral admixtures, these are well known to you. Fly ash you can use in place of replacing cement. And GGBS, ground granulated blast furnace slag, we say GGBS in short form. So this is what we say, ground granulated blast furnace slag. Okay, and silica fumes, rice husk ash. This one is metakaolin, which is manufactured. Okay, straight away manufactured. Okay, right. So these are cementitious and pozzolanic materials. Right, the mineral admixtures, cementitious and pozzolanic materials. Okay, so these are mineral admixtures which you can use it in preparation of pre-stressed concrete. Okay, right. So these are the basic requirements of different ingredients which we are going to use in pre-stressed concrete. Okay, so that is to introduce to you about the um, constituents of concrete which we come across when we prepare pre-stressed concrete. Okay, right, let us see properties of hardened concrete now. Okay, so the concrete in pre-stressed applications has to be of good quality. Okay, so the hardened concrete properties now we are talking about. So it requires the following attributes: high strength, you need high strength with low water to cement ratio, Durability with low permeability, minimum cement content, proper mixing, compaction and curing. Okay, the good quality means what? Low water cement ratio, high strength, the low permeability, minimum cement content, proper mixing should be there, proper compaction should be there, and proper curing should be there. Mixing, compaction, and curing. This should be proper. Okay, so that you can attain low permeability. Okay, if you want low permeability, you need to follow these things. Minimum shrinkage and creep by limiting the cement content. Okay, so these are the attributes that make the pre-stressed concrete a good quality one. Okay, right. So let us see the strength of concrete. Now, the strength of concrete is required to calculate the strength of the members. So if you want the strength of a member, you need a value of FCK. Okay, then only we are able to estimate the strength of the member. For pre-stressed concrete applications, high strength concrete is required for the following reasons. We already talked about this, why you need high strength concrete. Now let us just recapitulate that. So to sustain high stresses at anchorage regions where we pull the tendon and where know end zones, we say anchorage regions means the ends of the members are very crucial, where there is going to be high concentration of stresses, where you are going to hold the tendon and you are going to pull the tendon from the other end. One end you are going to hold the tendon by maybe bolting or the devices that are being devised, and you are going to pull the tendon by using jacks, hydraulic jacks. Okay, so these two regions, end regions, are going to be very crucial, where high amount of stress are going to be transferred. Once it is transferred, it is going to propagate into the concrete. Okay, so end regions are going to have high stresses. So you need to withstand that high stress, you need high strength concrete. Okay, so if the stress is high, you need strength of concrete should be very high. Next, to have higher resistance in compression, tension, shear, and bond. So these are very straightforward, I mean, directly related, directly proportional to the strength of concrete. If the strength of the concrete is high, FCK value is high, compressive strength will be high, and it can have higher tensile resistance, higher shear resistance, higher bond resistance. To have higher stiffness for reduced deflection. Okay, so stiffness will be very high, so that if FCK is high, stiffness will be high, so the deflection will come down, deflection will be reduced. To have reduced shrinkage cracks. Okay, so these are the things which you need, for what you need high strength concrete. Okay, the following reasons, these are the following reasons for having high strength concrete. Okay, right. We will talk about the compressive strength and tensile strength, stiffness of concrete. Okay, durability of concrete. All these properties of high strength concrete the further classes to come, right? Thank you.